recording, I think. Hello and good day, folks. Sorry, volume's turned down. Jack, stand for us, class, please. I already told you to sit flat once. Okay. Today's objective is also a PO, which is my way of telling you that you need to really focus up. Why don't you stand in the back? There's no back in that back that side. This is something that is going to come up again and again and again and again. It's more practice with Slope-Intercept form. Okay, and today we're going to be looking at relations written as equations, and we're going to put them on the corner plane. Right? If you'll notice, all of these equations are either in slope-intercept form or standard form. The form of the equation that you want to have is slope-intercept form. That's the one that is most easily graphed on the corner plane. Because what two things does slope-intercept form give us? The slope and the Y-intercept. That's all you need. Okay? So, here are 3 easy steps you can use to graph any linear equation. Step 1, which this is another if necessary step. Already, yeah. Because if your equation is already in slope-intercept form, you don't have to convert it there. If it's not, if it's in standard form, then convert to slope-intercept form first. Right? So this step you only do if your equation is not given to you in slope-intercept form. It says if necessary, convert to slope-intercept form, which, as we know, is y equals mx plus b. Okay. Step 2, you begin by plotting the Y-intercept. Okay? The first point that you plot is the Y-intercept. Why do you think I used the word begin for this? Why do you think I used the word begin, Wyatt?
Start with it.
To start with it, but why not say start? Why begin? Think about slope-intercept form. Think about the Y-intercept.
Because you start with checking if necessary, you have to convert the slope.
No? Christopher?
Easier to remember because they both start with B.
Ah, that Y-intercept point is the B variable, right? That's where you begin. Okay? You begin with that Y-intercept point. Then you move to the next point using slope. Move to the next point using slope. Why do you suppose I use the word move? Why? Because in slope-intercept form, it is the m variable. Okay? That's it. Begin with the Y-intercept. Move using slope. Claire?
I didn't do anything.
Okay, just right. Move to the next point using slope. So, our first equation. Does everyone have the notes down here? Okay. Anthony?
After the if necessary, what is that word?
Convert. Sorry. Convert. Convert
It also looks like a B there.
to
It is
slope-intercept form.
What's a B?
Okay.
If you write B,
All right. Jack, I turned off the mic, so this isn't on recording. If I hear you again, you're going to be on the hallway. Okay? Too many distractions from one person. All right. Convert to slope-intercept form. So, anyone else need the notes here? Okay. Looking at our first equation on our first graph, y equals 1/2 x plus 3. Okay? It might be helpful as you start this to write slope-intercept form above the equation so you kind of know where all the pieces are. Is this in slope-intercept form?
Yes.
Yes. We don't have to do step 1. Step 2, begin by plotting the Y-intercept. What is our Y-intercept here? Joey?
+3.
+3. So on my corner plane, you do have to count. Numbers aren't labeled for you there. I'm going to put a dot at +3. Okay? Some of you might need reminders. Which axis is X? Which axis is Y? Okay? Make sure that you put that +3 on the Y axis. Okay, the vertical one on the Y axis. Then from there, I look at my slope and I move according to the slope. A slope of +1/2 means how am I moving? Max.
Up 1 over 2
Up 1 over 2. From where?
from the Y-intercept.
From the Y-intercept. That's how we start with that, right? We have to know where we move from. So from the Y-intercept, up 1 over 2. Connect the points, and you've got your line. Just like that. Okay? Just like that. Y equals negative 3x plus 5. Y equals negative 3x plus 5. Is this in Slope-Intercept form?
Yes.
Yes. What do I do first? Ellen.
Plot 5 on the Y-intercept.
Plot positive 5 on the y-axis, my vertical axis. Okay? Up 5. And then from that point, how do I move? Sometimes this throws kids off a little bit when you've got that, not a fraction. It's not a fraction. What do I do? Noah.
You go down negative 3 and then over positive 1.
Exactly. We make it a fraction, right?
Yes.
Negative 3 is the same as negative 3 over 1. And Noah mentioned, because that's negative, that means we're going down and over, right? Down and over. So from this y-intercept point, negative 3 over 1, we still go to the right. It's not down and left. It's still down and right. But there are 2 points, and there's our line. Okay? Alex.
I have a little trick. It's the line goes this way, then it's positive, and then it goes that way, it's negative.
I think I interpreted your hand gestures correctly. But yeah, if a line is sloping upward, if it's like a hill sloping upward, it's a positive slope, right? It's sloping up. If it's negative slope, it's sloping downward. That's absolutely right. That's how you kind of check yourself. If you've got a negative slope, but your line is doing that, you did something wrong. Okay? Because that would be sloping upward. That's a positive slope. Okay? Ellen.
You can tell if the slope is going up or down because it's like how you read left to right. So if it's going
Exactly.
up, then that's up, and then
Yes.
if it's going down, then it's down.
Yeah. Students who say, well, technically this is also sloping downward. Well, no, it's not, because you read a graph from left to right. It is sloping up. Right? Looking at this, folks, other things that tend to confuse kids at the start. This one here, what's the slope of that line? There's no number before x, Catherine. 1 over 1, right? There's that invisible 1 there, which as a fraction would be 1 over 1. Okay? So your slope is up 1 over 1, up 1 over 1, up 1 over 1. Right, Joey?
For the fractions that are all negative, can you go both down and like to the left?
You never go to the left.
Okay.
Okay? It's always either up and right or down and right. And the reason for that is because if we went down and left, that would be a negative 7 for the down and a negative 3 for the left.
Should it look like it's going up?
That's actually going to be a positive slope, right?
Yeah.
Yeah. So it's always down and right or up and right. Okay? On the second page, okay, y equals 3/5 x. There's no b. Where do I start, Alex? Start at 0. Because it's not like adding 1, right? Because adding 1 would actually change the value of this. If there's no constant written there, it's like you're adding 0. Okay? Because that doesn't change the value of it. And so adding 0 would be the same as starting at 0, 0. Starting at 0, 0. Then the last 6 here have to do with, they're written in standard form. So this goes back to last objective, where first you need to write it into Slope-Intercept form, put it into Slope-Intercept form, convert, and then graph it. So for the last 6, you do need to do step 1, which is convert to Slope-Intercept form first. Okay? Ellen?
So on the page, like if there's only a negative sign on, like if there's the fraction is negative, then you only have to go negative on one of the values.
Yes. And typically we would say apply that negative to the numerator, so we're going down. Okay? You can go, Ellen, I will say you can go up and left and you'll achieve the same thing. But for consistency's sake, we want to say always go to the right, which means you're going down and right. Sophie.
I'm confused. I don't know how to graph the standard form.
So standard form, you're first going to put it in the slope-intercept form, which is what you did for homework for today, or actually the day before, right? With our equation, 2x minus 3y equals 9, how are we going to put that into slope-intercept form? This is PO22. Alex?
You move the x.
Move the x term over, right? So minus 2x, that gives us negative 3y equals negative 2x plus 9. Okay, if you need to review this, look at the first page of PO22. Right? This is what that first page was there. And then what do we do next? Noah?
Divide them all by -3.
Divide everything by -3. Right? Which gives us y by itself. -2 divided by -3 doesn't work out evenly, but do we care? No, because it's a slope anyway, right? It just becomes positive. So y equals positive 2/3 x, and then positive 9 divided by -3,
-3.
which would mean -3. Now it's in the slope-intercept form. Now you plot the y-intercept, and then apply the slope. Okay? So, to review this, these last 6, PO22 is where you want to go.
Oh, wait. We don't have to do the first 3?
Oh yeah,
Oh.
but those are the same as the
I got a
front
question.
side. Yeah.
On the first one, there's no y-intercept.
We just want
Oh, we did. I was looking at the other page. My bad.
Yeah. What is it if there's no number, if there's no y-intercept written? Plus 0. So it's going to start at the origin. Okay?
My bad.
Okay.
My bad.
Anything else? Anything else? Okay. In the event that we go distance, I don't know if we would need to be a Zoom at our normal time or a different time during the day or whatever. So just watch Google Classroom for information on that. We're going to keep the schedule that we've been on. You can still plan for a test next week on Monday. And if that does change, then I'll let you know.
How
But
many days of school do we have?
Catherine,
If we do Zoom, can we not do it like in the morning?
I don't know. I'm not going to be the one who sets that schedule. Folks, 3, 2, 1, you are quiet. Claire, I counted down. I do not have the power to make that decision, so I don't know. Rowan.
How would we do it?
So how this would work if we were to go distance is I would send you all a Zoom link. You would all be Zooming with me. I would share my screen. Ideally, I'd be here in the classroom just by myself. I'd share my screen and teach the lesson as I normally would, only instead of looking at this, you're looking at this on your computer screen. Ideally, that's how
You're
it
all
works.
alone.
We all know how technology loves to mess with my class. So, yeah.
Can we see some merch now?
We are out of time.
Why
I'm
Josh,
sorry. I'm sorry. That is how you math.
Oh,